In this video, we'll look at annuities and amortized loans. Now, let's start with those terms. An annuity is a sequence of payments that are made at regular intervals to a purchaser. Often this is happening on a monthly basis, and often those payments are equal, even though they may not have to be. Annuities, again, are what are being paid to you. So this is things like your retirement benefits, Social Security, if you know someone that's on government disability insurance, or even trust funds that are set up from larger estates. These are all forms of annuities. Whereas in contrast, amortized loans are those loans that we pay back for something large that we've purchased, and we're making those in regular equal payments. Think about like when you buy a car, you get a regular monthly payment, or a mortgage is a regular monthly payment. These payments are always equal, and they include both the principal and the interest towards the purchase of that item that you're loaning. Now, recognize because interest and principal are built in together, the early payments that you make are going to be primarily interest, and the later payments are primarily principal. And the reason is that if we take a loan, say a $195,000 loan over 30 years, you will get an amortized loan table from the bank. And they'll show you this broken down. They're going to say, what is your monthly payment you're making? How much of that goes towards the principal to start? How much of it goes towards the interest? And then that will tell you what's remaining after you take off the principal that first month. And they will have a chart that goes through every single month that you've set up your loan. So if you've done a 30-year loan, there will be 360 lines in this table that will show how much goes towards principal and how much goes towards interest each month. And there are calculations and formulas that we can get this single line if we need. But it is recursive, so you have to calculate month 1 to calculate month 2. And what we notice though is go from month 1 to month 2, we're now paying about $1 more towards the principal. And each month we're paying about $1 more. So while it's a small increment over 1 month to the next that goes towards the principal, over the life of the loan that becomes much, much more. And as you're paying more towards principal, you pay less towards interest because you're never going over this monthly payment. And that's how amortized loans work. Now, often, instead of looking at what are you paying from 1 month to the next month, we look at the total amount of interest and the total amount of what you may need, as well as calculating how should you be paying this monthly payment. So let's look at the idea of calculating the monthly payment on annuities and amortized loans first. So if I want to know what my payment will be each month, I'm going to take that loan amount, I'm going to multiply it by my interest rate over the number of compounds each year. And again, remember, interest rates are written as decimals. And then I'm going to divide it by this quantity, where again, it's 1 minus the quantity of 1 plus the interest rate over the compounds, all raised to the negative the compounds times time. And this NT here, important to remember that that's telling us the total number of times I'm making payments. Now, most commonly with these types of loans, you are going to be making monthly payments for some number of years, but you could have quarterly or semi-annual payments as well. So it's important to pay attention to that compound number. Let's look at some examples to help us out. So Tanya wants to buy a car for $32,000. She gets a 60-month loan at 1.9% annual interest. You know, what will her monthly payment be? And as soon as you see that monthly payment question, you know you're dealing with this formula for the monthly payment of a loan. So we don't know the monthly payment. That's our P. It's unknown. So that means we should be able to fill in our other components to our formula. So do we have our starting loan amount? Yes, it's $32,000. Do we have interest rate? Yes, it's 1.9%. So we change that to its decimal of 19 thousandths. Remember, just divide by 100. Do we have our time? It's 60 months right here. 60 months, though, is not the way we want to write it because time is always in years. So 60 divided by 12 is 5 years. So 5 is what I'm going to use for this. And then I have my compounds, which is telling me monthly payments. So I'm compounding 12 times a year. Now I have my information. I plug it directly into my formula. So now I have 32,000 times 1900s over 12. And then in my denominator, I have 1 minus the quantity, 1 plus 19 thousandths over 12 raised to the negative 12 times 5. I simplify my numerator and my denominator separately. And I'm going to use Desmos to help me, or some other calculator that has an answer key so that I can do things like 1900ths divided by 12 and hold all those decimals. Because if I round too soon, my answer will round too much when I need my final solution, and that's going to be a problem. So I want to pull as many decimals from one line to the next as I do this. Now I can continue to simplify my numerator and denominator. I have one more time in my denominator to simplify. And now I can actually do my division. And when I divide these two values, I'm going to get to $559. And then I've got my decimals. But remember, it says round to the nearest cent. So always see where they want to round. Sometimes the cents, sometimes the dollars. Here I'm rounding to the cents, so that's 2 decimal places. So I'm going to round this up to 49 cents. So Tanya will have a monthly payment of $559.49. Now, it's important to recognize that when we take a loan, we will end up paying more than the amount we borrowed, because you're paying both what you borrowed plus the interest that you're using to borrow that money. And the interest is going to be embedded in your monthly payments. So that's important to recognize. So if I want to calculate my total cost, I can take what's my monthly payment, or what's my payment I'm making, how often am I compounding that, and for how many years. So in other words, I take that payment I'm making and multiply it by the total number of times I make that payment. And my interest will then be the difference between my total cost and how much I started with. Just remember, time is always in years. The payment we just calculated like we would in the previous example, and then the starting amount you should be provided. So let's go back to Tanya and her car. And we want to know, well, how much interest will Tanya pay over the life of the loan with this exact same information? So as soon as we see the how much interest, we know we're looking at that total cost minus the initial amount. And the how much interest is what we're searching for, so that's our I, that's the unknown piece. We do know that we had the starting amount of $32,000. And we know that from our previous example that Tanya is going to make a monthly payment of $559.49. So we have those two pieces of information. We know that she is going to be paying this for 60 months, which we determined was 5 years. And we know this is happening monthly, so 12 times a year. So we again have all our information from this single problem. We can plug in each of the pieces. We multiply these three values together, and then we're going to subtract them. And you'll see that the interest that Tanya pays on this $32,000 car is $1,569.40 over the life of the loan. So if you think about it, though, she borrowed $32,000 and she's only having to pay $1,500 about to keep this car. And that's why she's able to make larger purchases with paying a little bit back to the bank that allowed her to purchase it. Now let's put this all together with the idea of a mortgage on purchasing a home. So we got Freddie, who makes a down payment and then has $195,000 left on the loan. The loan lasts for 30 years with an annual interest rate of 4.25%. First thing we want to know, how much will Freddie's monthly payments be? That's the question. Those monthly payments, that's our P value. That means we're going to be using that payment calculator. So we're going to look for what's the initial loan that he's going to borrow, $195,000. How much is the interest rate? It's 4.25%. How many years? 30 years. And then how often? We're making monthly payments, so that's 12 times a year. We substitute all the parts here. And what we're going to end up with then is simplifying our numerator and then our denominator. And one of the things to recognize is that typically, a lot of people, if you do a 30-year loan, it's going to be 360 payments. That's a very common thing because it's 12 months times 30 years. So you're going to make that same payment 360 times. It's a lot of times. So let's keep simplifying our numerators and denominators. Keep simplifying that denominator. Again, use Desmos or your calculator's answer key to help you pull through all your decimals. And divide it one last time. Now we're going to round to our hundredth place. So 2 decimal places here for the nearest cent. That'll give us that Freddie is making a monthly mortgage payment of $959.29. So let's go to the second piece, which is how much interest will Freddie pay over the life of the mortgage? And we're going to round this one to the nearest dollar. So how much interest? So we're looking at that unknown component of interest, which we know is the total amount paid minus what was the starting loan. So we know that the starting loan was $195,000. We know that there were period or monthly payments that are of $959.29. We know that this is happening again for 30 years, and we're compounding monthly. So it's 12 times a year. So Freddie is making 360 payments of $959.29. That's just right around $345,000. So when I subtract these two values, I get to $153,344.40. This means if we're rounding to the nearest dollars, that's our ones place, that Freddie will pay approximately $153,344 over the course of his mortgage on this home. It sounds like a lot of money, and it is a lot of money, which is why people then will consider refinancing, changing the length of a loan from 30 years to 20 years or even 15 years. You may pay more towards the principal, but as you pay more towards the principal, that's less that you pay towards the interest, so that's more money back in your pocket long term.